Hello my dear students, I hope you are doing great. Now let's solve a beautiful and tricky problem on simple pendulum. Okay, the problem says a ball is suspended by a thread of length L at the point O on the wall, forming a small angle alpha with a vertical. So basically the wall is inclined at an angle alpha with a vertical and length of the thread is L. Also the angle alpha is very small. Okay, and we will see what impact it creates being a small angle. Now the thread with the ball was deviated through a small angle beta, and also given that beta is greater than alpha, so here beta is also small. Okay, so it's deviated and set free, so obviously it will oscillate. The simple pendulum, it will oscillate, but here beta is greater than alpha. It signifies that the ball is going to hit the wall, okay, because this angle is greater than this one. And again it says that assuming the collision of the ball against the wall to be perfectly elastic, find the oscillation period of such a pendulum. So basically here the collision is perfectly elastic. So perfectly elastic collision means no energy is dissipated, so the ball will reach the same position from where it was released. Now we have to find the time period of oscillation of such a pendulum. So here this pendulum is obstructed one, this is not a free one, so we cannot say that time period of oscillation is 2 pi root L over G. So what we will do here is to break this motion into pieces and see how we can find out time period of oscillation. Okay, so here the ball goes from this extreme position to the mean position. Bottommost point is the mean position, and then from the mean position to the position of the wall. So ball will go like this, and then it will hit the wall, and then it goes back and to the same position here because the collision is perfectly elastic. Fine. So what we are going to do is to break this motion into pieces. So from here, from the extreme position to the mean position, let's say the time taken is t1, and from this mean position to the position of the wall is time t2. So the required time period will be t1 plus t2 plus t2 plus again from this wall to the mean position. Again this time will be t2 only because the collision is perfectly elastic, so twice t2 plus from mean position to the extreme position, again the same time t1. So basically it will be twice of t1 plus t2 is the required time period of oscillation. Fine. So how we are going to find time t1 and t2? Let's see. So t1 can be found just simply by looking at this one. It's 1/4 of the time period of oscillation of the simple pendulum, which is the simple pendulum's time period is t dash is equal to 2 pi square root of L over G, and t1 is going to be your t dash over 4. So t dash over 4 is equal to pi over 2 square root of L over G. So we have found t1, and how can we find t2? So in order to do that, what we can do here, we don't know, basically this is not going to be the extreme position. So what we are going to do is just imagine the equation of simple harmonic motion as x is equal to a sine omega t. We know this equation. So here instead of x we can just take this an angle theta. So in terms of angular SHM we know how to do that. So that theta is equal to theta naught. Theta naught is the angular amplitude, which in this case is beta. So beta sine omega t. We know this equation when the particle goes from mean position. So initially when the particle is at mean position and it goes from the mean position, and the angular displacement is theta. So here we can just consider that this position towards the left is our positive direction. So at time t2 theta is going to be alpha here, so it becomes alpha is equal to beta sine omega t, and here at time t2, so I am putting time t2 here. So here t2 is equal to sine inverse of, we can say sine inverse of alpha over beta, and 1 over omega. And what is omega? We know omega is the angular frequency of the simple pendulum, and angular frequency we know root over G by L, angular frequency of the simple pendulum as root over G over L. Well, so we got this T2 also. So it becomes square root of G over L, 1 over omega. From here it becomes square root of L over G, sorry, sine inverse of alpha over beta is your T2. And when we plug the values of T1 and T2, we get the required time period of oscillation for such a pendulum. So then our time T becomes twice of, when we plug the value here, so it becomes twice of T1. T1 is pi by 2 square root of L over G. So it becomes pi over 2 square root of L over G plus square root of L over G sine inverse of alpha over beta. So basically this is the time period of oscillation. So when we simplify, when we take this square root L over G out of the bracket, it becomes twice of square root of L over G pi over 2 plus sine inverse of alpha over beta. And this is the final answer of this problem. Okay, so I hope you understood it if you really followed step by step. If you have any sort of confusion, you can comment below and do let me know. I will definitely answer your query. Okay, thank you students.